definition of the property, and then I'll give you an example that has some numbers, okay? So technical definition, the first one's called the product property. So in this, just little rules here, M, N, and B all have to be positive numbers. You cannot have a negative base for your log, and you can't take the log of a negative number. The other thing is B can't be equal to 1. If that was the case and we converted it to an exponential, 1 to any power is always 1. So the B value has to be positive and it cannot be 1. All right, so here's what this is going to say, the product property. So this is what we call a single log. Like I just have one word log. I'm going to break it apart, or what we call expand it, to show you this property. So this is the same as the log base B of whatever M is, plus the log base B of N. So if you have two things multiplied together, you can break it apart to two separate logs with addition. That's called expanding it. If you have the two separate logs, like I wrote for my rule there, you can what we call condense them and put them together as a single log. So we're going to go back and forth between those two things today. All right, now let me give you a tiny example with numbers. Let's say I had the log base B, I'm just going to make something up, of, I don't know, 20. That, and you don't even have to, we could just do a common log if you wanted to. That would be the same, and there's a couple ways I could write this. I could do log base B of 10 plus log base B of 2. Because if I put those two things together, 10 times 2 would end up being 20. I could do like 4 and 5 as an example, but basically what we're going to do if we see addition, it turns into multiplication, or if you want to break it apart, you can find the product if you have a number there. If we have variables, there's different ways to do that. We're going to do those in the examples here at the bottom. Okay, so product property, product turns into addition. So I'm going to guess you guys will be able to figure this out. If you have a quotient, division is going to turn into subtraction. So this would be the log base B of M minus the log base B of N. Now, really for the product rule, it doesn't matter which one comes first or second when you multiply, but when you do the quotient rule, it does matter the order that you put these in. So whatever's in the numerator of the fraction has to go first, and whatever's in the denominator of the fraction, that has to go second. All right, so let me just use a little example. Let's say I had, I'm just going to write log. Remember, if you don't write a base, it's a common log, so I'm not going to write the base, but it would be base 10. Let's say we had the log of 2/3 as an example. This would be the same as the log of 2 minus the log of 3. When you have two separate pieces, that's called expanded. When you have a single logarithm, like I have the log of 2/3 there, that's called condensed. So we're going to do both today. All right, now the last one, this is the power property. So if you're taking the log of something and that something has an exponent, so I have this log base B of M to the A power. The way this property works, whatever that exponent can actually come down in front of the logarithm and be multiplied by the logarithm. So what that looks like, this is equivalent to A times the log base B of M. And then a lot of these have variables, so just as a little example, let's say I had, I don't know, I'm going to make something up. Let's say I had the log of like x to the 7th or something like that. The way the power rule works is this guy here is going to come down in front, and this would be the same as 7 times the log of x. And depending on the question, sometimes it's useful to have the two separate logs, sometimes it's more useful to have one together, so we're going to practice both today. And we're just going to do this first example, we're just going to apply some of these properties. Okay, now, first thing I would tell you to do, and you can do these, you don't have to do these in multiple steps, I'm going to just to show you the properties. But if I see a number in front of the word log, I automatically go, okay, that's going to be my power rule, so I'm going to put that as an exponent on whatever follows. What we're going to do on this example, I got separated logs, and we're going to do what we call condense and write it as a single log. So I just want one word log. So this would be log base 4 of x. I'm not going to change that for a second. And don't change the subtraction sign. Just keep that as a subtraction sign. This is really the log base 4 of y to the 5th power. So that's just me applying that little power rule. So got a number in front, can become an exponent on whatever follows. Now, from there, I'm seeing subtraction between the two logs of the same base. So I'm just going to write 1 log base 4, just out in front, single log. And then if you have subtraction, that's going to turn into division. So whatever comes first, which is just the x, goes on the top. And whatever comes second, which is the y to the 5th, goes on the bottom. And that's us writing that as just a single log. Just have the word log one time. And that's all it is. Anybody have a question? Okay. Now, there's two ways I can write this answer I'm about to do, so I'm going to show you both. But similar to the last question, I have a number in front of that second log, which is a half. So this is the same thing as log base 7 of x to the 1/2 power. So just applied the power rule. And then I'm adding between these two. Addition is going to scrunch together and be multiplication. So what we're going to do, we're going to write log base 7, and we'd have 8 times x to the 1/2. Now, I just want to ask you a quick question. Does anybody remember what the 1/2 power is the same as? Square root. Okay, so I would totally, if you want to write the answer like this, that's fine. A lot of the times you'll also see, like if you were looking up how to do this problem online or something, or if you did like photo math or whatever, it would probably write it in radical form like that instead of having the fraction exponent. Both of those are correct. And like on a test or quiz, I would take either one of those. But just remember, like if you have a 1/2 power, you can actually write that as a radical. Now notice the 8 is not under the square root there because only the x was being taken to that 1/2 power. So the 8 would stay in front and it wouldn't go under the radical. They're still being multiplied, but the only thing being taken to that power is the x. Okay, now I have super tricky ones down here at the bottom that have 3 different things going on. So I'm going to do one thing just before I start to put anything together, just like I kind of did in the other problems. I'm just going to apply the power rule here real quick because that's just within the same term. So this 6 out in front, this is really the log of x to the 6. That middle term was just a log y. There's no exponent or anything. And then minus log z to the 4th. Okay, now, the other 2 questions that we just looked at, we just had like 2 logs that we put together. These 2 questions at the bottom have 3 different logs within the problem. So I just applied the power rule. You can put that in at any time. But when you're going to work through this to condense this to one single log, you have to start and read it like you would a sentence in a book from left to right and then apply the properties as you encounter them. So what I mean by that, I'm just going to write log. The first thing I see is addition. So addition scrunches those 2 logs into multiplication. So I'm going to take the x to the 6 times the y. And then at the end of the problem, then I see minus the log of z to the 4th. So that gets applied after the multiplication. So this whole thing would be over z to the 4th. And I can't simplify anything else there because all those letters are different. We couldn't do any exponent properties or anything like that. So that's as simplified as it would go. But you have to apply the properties with the plus or minus as you read them from left to right. So I have to multiply x to the 6 and y first and then divide the whole thing by z to the 4th. Okay, and I've got one more. And this does have a little power rule in just one of the terms there. So this guy is log A minus log B plus the one on the end would really be the log of c squared if I apply the power rule. So multiplication becomes an exponent. Now, this one's a little tricky. As you read this guy from left to right, the first thing I encounter is subtraction. So I'm going to write log, and it would be A over B. Subtraction is going to turn into division, and it matters. Whichever comes first goes in the numerator or the top of the fraction. Whichever comes second goes in the denominator or the bottom of the fraction. And then, so I would do that division first, and then I would multiply that by c squared. Okay, now I'm just going to write this to the side just real quick so you can see this. If I actually took A over B and multiplied that by c squared, I would just tell you, let's write c squared over 1 to turn it into a fraction. What would actually happen there if we had numbers or whatever? This would be ac squared on the top over b. Because if I multiply that c to that fraction, it's going to end up in the numerator of the fraction. So for my answer, as my single log, I would simplify it just to be ac squared over b. Is anybody having a question? That one's really tricky. Okay. Now we're going to see if we can apply these to some numbers. So, and then I'm going to have you evaluate these. So evaluate means we're going to do what we did yesterday. Once we have a single log, we'll find the value. Okay, so if you have addition, it's going to turn into multiplication. So what would I be taking the log of on this first question if I applied the product property? Log of what? 100, exactly. Okay, now, there's my single log. Now, the question's going to ask you to evaluate, so you don't have to rewrite it again, but what is the little base if you don't have a base? 10. All right, so I'm going to evaluate this here. And then just remember, easiest way I can tell you to evaluate, just take your single log, set it equal to x, and then I'm going to get rid of the log by converting this to an exponential. So this will be a little good practice from yesterday. So the log disappears, the word disappears. Leave the 100 right where it's at. The base of the log, which is 10 for this one, swings over to the other side. It's going to push the x up in the air, so the 10 becomes a normal size number and the x becomes an exponent. To evaluate this, you just have to tell me, okay, like what would you plug in for x to make that little exponential equation true? 10? 2, yeah, 100 is 10 squared. So the single log would just be log of 100, and the answer to evaluate the question would be that it's 2. Okay, now we got a single log here. So this is log base 6, right? They have to be the same base to apply the properties. I don't have anything weird where it's not the same base. But to do this question, subtraction turns into division. So I'm going to squish this together. It would be 216 over 36. So let's see what that is real quick. Nice. Okay, so this is the log base 6 of 6. That's my single log. And this, does anybody know what this is just off the top of your head, just looking at this from yesterday? Yeah, it's 1. Yes. Anytime the little subscript and whatever you're taking the log of, if those match, just in here, I'm going to just write this. Like if I have the log base, I don't know, a of a, that's always going to be equal to 1. If you were to actually write this out like I did on the other question and convert this to an exponential real quick, you'd have 6 equals 6 to the x. And I'm totally off the screen. I'm so sorry. Let me move that. Now, it has to be 1 because the exponent, the bases would be the same. They're not going to write an exponent on that 6 right away in the problem, but 6 is the same thing as 6 to the first power. So anytime your base and what you're taking the log of, if those are the same, that'll be always equal to 1. Little useful thing to remember. Okay, now, this guy's got a couple rules going on. That 1/2 I'm going to take, and that becomes an exponent on whatever follows. So this would be the log base 2 of 4 to the 1/2. 1/2 power is the same thing as what? Square root, right? So really this guy would be the log base 2 square root of 4. And so that guy would be the log base 2 of 2. And then I'm going to bring down the rest of this. Then we had plus log base 2 of 4. So just applied the power rule. You don't have to write out all those steps. I just want to try and show you where it comes from. So the 1/2 power, same thing as the square root. Or you could do the little bottom out if you wanted to do the radical form with that like we did in our last unit. And then if you have adding between two logs of the same base, which I do here, we're going to scrunch it together and we're going to multiply. So this would be 2 times 4, which would be the log base 2 of 8. So there's my single log. Now, does anybody know what that is just right away looking at it? This is 3. If you're like, what the heck? if you do the log base 2 of 8, I'm just going to convert that to an exponential real quick. Get rid of the log. The base of the log becomes the base of your exponent. So that 2 swings across the equal sign, pushes that x up in the air. To make that true, 2 to the 3rd power is 8. So that's why the answer there is going to be 3. All right, and then I got one left. We're going to do single log, no power rule or anything here. This is just log base 3 of 9 minus log base 3 of 27. So if I scrunch those guys together, subtraction turns into division. The 9 has to go on the top, and the 27 has to go on the bottom. When you're doing the quotient rule, it does matter. Whichever one goes first has to be in the numerator, whichever one goes second in the denominator. And then I would just reduce that fraction real quick. Both of those are divisible by 9, so it'd be just 1/3. So log base 3 of 1/3, there's my single log. And this one's a little tricky. If I want to evaluate this, let me just set it equal to x, excuse me, so I can convert it to an exponential. The log disappears, the 1/3 stays where it's at, and then this would be the base of the log becomes the base of your exponent. So the 3 is going to swing over there, push the x up in the air. All right, and I would, tell me how I could write 1/3 as 3 to a power. What do you think? -1, yes. Remember, if you got a fraction, you're just going to have a negative exponent. So if the bases are the same, that forces the exponents to be equal. My answer there would be -1 to evaluate that. Does anybody have a question? Okay, I just have 2 problems here real quick that we are going to have as a single log, and we're going to break it apart using the properties. So you'll see in the directions it'll say expand each of the following logs. So we're going to write separate logarithms here. All right, so first thing I see some division, and you can do this, you don't have to do this in multiple steps. I'm going to in my problem. So this would be log base 8, whatever's in the numerator, which is the square root of x, and then minus the log base 8 of whatever's in the denominator, which is y to the 4th. Now, really, the only other thing I can do here is apply also the power rule, which for the y to the 4th, that's not too bad, but I would tell you for that square root of x, remember, square root of x is the same thing as x to the 1/2 power. So what I'm going to do on this first term, or here, I'll just tell you what, I'm just going to rewrite it. You don't have to rewrite it. This is the same as x to the 1/2 power. Those exponents, to consider this completely expanded, those exponents would need to come down in front. So I'm reversing kind of what we did in the other questions. When you write it as a single log, you want to see it as an exponent. When you expand it, you want to see that whatever that exponent is multiplied by your log. So this guy would be 1/2 log base 8 of x, and then minus 4 log base 8 of y. So just kind of reversing what we were doing in the other questions. And then for the last one, this always trips people up, so I want to write this out real quick. So this is 4 times a times b to the 3rd that we're going to take the log of here. So there's 3 separate things being multiplied together. You don't have any parentheses or anything, so I should have 3 separate logs when I do this. So it would be the log, just the plain number 4, plus the log of a, and then if you want to do this automatically, go ahead and apply the power rule, but log b to the 3rd. I'm just trying to show you kind of one property at a time. So if I actually apply the power rule, this would be log of 4 plus log of a. Everything's being multiplied, that's why I'm adding in between these when I expand it. Then I'm going to bring that 3 down in front of just the term with the b, because b is the only thing being taken to that 3rd power. Does anybody have a question? Okay, now I put these guys on the bottom here because I have seen stuff like this like on an SAT or ACT. So they will give you, we're going to use some log properties here. I'm going to give you 2 pieces of information only. So log of 4, 0.6021. You're probably like, what is that garbage? And log of 5, 0.6990. I don't know why we put the 0 on the end, but This would be on like a non-calculator part of an SAT, ACT type question. Okay, so I just want to show you just really quickly here why this is such a weird decimal. And you could use the same argument for the log of 5. So if you guys remember, if you just have a single log, it has a base 10 if they don't write the subscript. All right, so if I just did like a quick conversion to put that in exponential form, what that means is what's written to the side there, that 4 would be 10 to that power. All right, so if you look at what I have here, and it's rounded a little bit, but if you actually did 10 to the 0.6021 power, and it's a little bit off because it's rounded, that's why it says it's approximately equal to, but that's why those decimals are so weird. A lot of these questions, as we get going further in this unit, will have really weird answers to the questions, but that's what that means. That's where these are coming from. Okay, so if I wanted to break this apart, and I know the log of 4 and the log of 5, how could I rewrite the log of 20 with the information I know from the directions there? Like, could you rewrite the log of 20 in terms of the log of 4 and or the log of 5 using the log properties we were talking about today? What do we think? Yeah, exactly. So 20 is 4 times 5, right? So the product rule would let us say the log of 4 plus the log of 5. So then if I knew that, we could literally just take and add those two. We could do the 0.6021 and add the 0.6990 to it and actually do that on our question. All right, how could I, if I had the log of 4/5, how could I use the log of 4 and 5 to rewrite that? I have the log 4 divided by 5. So how, if I only know the log of 4 and the log of 5, how could I rewrite the log of 4/5 using that information? Yes, ma'am. Yes, bless. You guys are quiet this morning. Okay, the 4's on the top. So log of 4 minus log of 5. If we were to squish that back together and apply the quotient property, subtraction turns into division. Whatever comes first goes on the top of the fraction. Whatever comes second goes on the bottom. So this would be that 0.6021 minus 0.6990. Okay, now the last one is super tricky. So I have the log of 1/4, but if you guys are looking, they don't give me the log of 1 in the information or anything. We could figure it out. That's one way you could do it, but I'm gonna let me have you think about maybe an exponent. Like, how could I rewrite 1/4? What were you thinking, Eli? Say that one more time. Yes, the log of 1 is 0. Okay, so option 1. All right, if you want to do this, you could do the log of 1 minus the log of 4. You could do that, which, let me grab a different color. I'll show you guys this. If you just have the log of 1, doesn't matter what the base is. For this question, it was just a common log, so this would be base 10. If you solve this, this would be 10 to the x. So any base, no matter what, if you ever have the log of 1, or if I had like the log base 4 of 1 or whatever, it has to be equal to 0 because that's the exponent. So you definitely could do it like that. So it would be 0 minus 0.6021 if I did that option. Was anybody else thinking of a different option? Exactly, that was the other one. So you could do either one of these. If you did 4 to the negative 1, I could apply the power rule. And so that would become negative 1 times the log of 4, which would give me the exact same answer I got doing the other way too. This would be negative 0.0 621. So both of those are options there. Anytime you have a log of 1, it's always equal to 0, because if 1 is what you're taking the logarithm of, it's anything to the 0 power is 1. So that's useful to know too, but you could do either one of those and it would give you the same answer.